Hello, my name is Adrian Sayers. I'm a Senior Research Fellow specialising in statistics at the Musculoskeletal Research Unit at the University of Bristol. Today I'll be discussing two papers published by our group, including this paper which investigates the association between obesity, revision and mortality, which was published in JBJS in 2018. I'll also be discussing this more recent paper, which focuses on how to analyse PROMs data using the association between obesity and the change in PROMs score as an example. I'd like to thank all the co-authors of these papers, the NJR, MRC and BRC, for supporting this work. Back to the first paper, which focuses on mortality and revision. The flowchart is a little small, but full details are in the paper. Briefly, just shy of 800,000 patients from the initial sample. BMI is historically not well recorded in the NJR, and we lose approximately 300,000 patients without BMI. And our final sample is just over 400,000 for both mortality and revision analyses. We use a variety of analytical methods in this paper. However, the standard KM analyses and Cox regressions are used to illustrate the main points. Models are adjusted for a variety of different covariates. The final model is adjusted for age, sex, ASA, year of surgery, fixation and indication. Obesity is associated with an increased risk of revision and total hip replacement. Kaplan-Meier results illustrate that at 10 years, 6.7% of class 3 obese patients are revised. These are patients with a BMI greater than 40, which is compared to approximately 4.9% of normal weight patients. In analyses which are adjusted for confounding variables, including age, sex, ASA, year, fixation, and indication, the class 3 obese patients are 43% more likely to be revised than normal weight patients. Results illustrate a gradation of response from underweight to obese patients. In terms of mortality, the story is different. Obesity is protective at 90 days, and underweight patients are at substantially increased risk compared to their overweight and obese counterparts. Over 100% increased risk following adjustment. Therefore, being obese is a risk in terms of revision, but protective in terms of mortality. Now on to the second paper. Firstly, the analysis of PROMs score is deceptively complex. The optimal method of analysis is not clear in cohort studies, and much of the guidance that is used is generated from RCTs and is incorrectly applied. There is a bewildering array of simple options, including the simple analysis of change score, post-score analysis, and baseline adjusted ANCOVAs. There are more complex options, including multi-level models, and finally, there are toe-bit variants of all of these approaches which claim to account for floor and ceiling effects. Therefore, it's very unclear which method is preferred or what the consequences are for using different methods, and potentially how this impacts on patients and the evidence we generate. Here is an overview of a simulated study. In this dataset, we know there is no effect. We categorized BMI into WHO categories and looked for a linear association across each group. You can see that some of the methods induce a substantial bias, which suggests a negative association in some instances. When the simulation results are compared to an equivalent model using real-world data from the NJR datasets, we can see the pattern of results are similar. The simulation study is extensive and demonstrates that a multi-level toe-bit model gives you the right answer in all instances. This has profound implications for the analysis of PROMs data in general and the majority of published literature that uses PROMs. From a starting point of over just 1 million procedures, we applied inclusion and exclusion criteria to the real NJR data. We then linked it to the PROMs datasets via the HES records, which resulted in 160,000 procedures with complete case data. Instead of using BMI categories, we adopted to keep BMI as a continuous variable and use restricted cubic splines to model the effect of obesity on the change in PROMs score pre and post surgery. So if we focus on our most adjusted model, you can see that the post-score models and the baseline adjusted ANCOVA illustrate that patients receive less benefit from surgery if they are more obese. However, when a simple analysis of change is used, the results are more muted, depending on whether you use OLS regression or a toe-bit parameterization. The results say obese patients either derive more or less gain from surgery than non-obese patients. However, we know all of these analyses are wrong because of the simulation study. So if we look at our preferred method, which is the multi-level toe-bit model, we see a different story. Again, these adjustments make very little difference. So if we focus on our most adjusted model, we can see the solid line, which is the preoperative association between BMI and Oxford hip score, and the dashed line, which is the change in Oxford hip score. Preoperatively, there is a strong association between BMI and obesity, with obese patients having substantially lower Oxford hip scores than their non-obese counterparts. This association looks very similar to either that of the post-analysis model or the baseline adjusted ANCOVA. The change in Oxford hip score is much more flat, and there is no clinically meaningful association between obesity and change in Oxford hip score. The simple methods, post-score analysis and baseline adjusted ANCOVA, look like they are inducing a spurious association in the analysis of change by either explicitly including the baseline measurement in the model or ignoring the baseline differences. The simple differences of change score is the closest to that of the multi-level Tobit model. Crucially, the 95% confidence interval of the change scores includes the average effect of BMI across all patients. BMI does not modulate the efficacy of surgery. So to conclude, obesity is associated with an increased risk of revision. It's also associated with a protective reduction in mortality. Patients receive the same benefit from total hip replacements regardless of their BMI. Baseline adjusted ANCOVA models, post-score analysis, and simple analysis of change score can all illustrate substantial bias in the analysis of PROMs data. There is no PROMs-based evidence to suggest that you should restrict surgery for obese patients. I would like to thank all patients who contributed data to the NGR as they make these analyses possible. Thank you.